So up to this point, we've talked about linear functions, and we've looked at how to tell if it's a function or not a function. Well, for every function that we have what's called a parent function, and that's like kind of the original. Just as your descendants of your parents, the parent is where all graphs start. So we're going to start today by looking at the parent function for a linear equation. The parent function for a linear equation obviously has to be in the form y equals mx plus b. But what we have for a parent function of just the linear is the equation y equals x. It's in its simplest form. Now, we still have an m and a b here, even though it doesn't look like it. If we had to put a number in front of the x, it'd technically be a 1, and because we're not adding or subtracting anything, it's actually 0. So our parent function for a linear graph has a y-intercept at 0, and then it increases up 1 and over 1 every single time. So it's very basic. Again, I could move the opposite direction and go down 1 over 1, but this would be what my parent function for a linear equation looks like. Now, all other linear equations that we deal with that have different m's and different b's are spun from this one. This is, again, the original. So we're going to look at how changing the m and the b affect the graph from this original graph. We're going to start with changes to m. So that's changing the number in front of the x value, or the slope of the line. Now, we've already determined that slope changes the steepness of the line, and so that's what I'm going to prove today in looking at my two equations. So let's look at two different equations to determine how m affects the graph. Let's start with the equation y equals 2x. So this time I've changed the equation, or I've changed the equation from the original y equals x to y equals 2x. And again, remember, this is the parent function that's actually graphed on here. This is, again, y equals x. So basically I've changed it from a 1 to a 2. So let's look and see how this changes the graph. First of all, it's still technically a plus 0. So my y-intercept is still at 0. However, this time my slope is actually 2 over 1. So that means when I graph it, I'm going to move up 2 and over 1. So my next point would be right here. And I could continue that pattern, up 2 and over 1. That's, again, the rise over the run for the slope. So we're going to continue that up 2 and over 1. And when I run out of room, I can always go the opposite direction, and that would be to go down 2 and then to the left 1. So my graph of my y equals 2x equation would look something like this. It's obviously different from the parent function, and we want to identify how exactly it's different. Well, basically what I want you to think about is if these two lines were hills, which one would be steeper? And we should obviously see that my blue line, my y equals 2x line, would be steeper. Therefore, when I change the m, it's going to change the steepness of the line. And in this case, this line has become, in fact, steeper than the original line. Now, let's try it again with a different m this time. This time, instead of y equals 2x, let's look at y equals 1/2 x. Let's look at a fraction. And again, I'm going to leave this as plus 0 as to not change my y-intercept. So again, the parent function is that dotted line on the graph. My second equation, y equals 2x, is the blue line. Let's now graph this one. So this graph again starts at 0, the y-intercept, and then this time we have a slope of 1 over 2. So this time my graph would move up 1 and then over 2. So my next point would be here on the graph. And again, I would continue that pattern, up 1 and over 2. So my graph for 1/2 x would look something like this. When I run out of room, I can always go the opposite direction, which would be to move down 1 and then to the left 2. So again, I could continue that pattern, moving down 1 and to the left 2 until I'm out of room. So 1/2 x looks something like this. Now, again, comparing that to my parent function, how has it changed? Obviously, again, the steepness has changed on it. This time, if you were to think about a hill and which one is steeper, the parent function is actually the steeper line here. So what happens when it becomes a fraction is it is less steep. And you're going to see this term used for that, as well as the word shallow. and think about it like the shallow end of the pool, it's not as deep as the other end. So less deep or shallow is what happens when we turn it into a fraction. So let's review that real quick. When we have changes to m, one of two situations can happen. We either have a new equation where the y becomes a whole number like we had in 2x. So therefore in this one, when m becomes any number greater than 1, the graph is going to become steeper than the original parent function. So again, that's when m is any number greater than 1. It's going to become steeper. Now, the other option that we looked at was when we had y equals 1/2 x. So this is where we were looking at it becoming a fraction, or any number between 0 and 1. So when this happened, when m is between 0 and 1, the graph is going to become less steep or shallow. So again, if m falls in between 0 and 1, meaning most of the time it's going to be a fraction, but make sure it's a fraction that's not an improper fraction, it will be less steep or shallow. So again, think of it changes to m, changing the steepness of the line. All right, let's look at now what happens when the m becomes a negative number. Now, we've already talked about what a negative slope looks like, and we know that it obviously is decreasing rather than increasing like a positive. But there is a specific change that happens when m is a negative. So again, this parent function is graphed y equals x, and again, that's a 1x plus 0. So let's look and see what happens when I change that to a negative. So instead of it being a positive 1x, I'm going to change it to a negative 1x. It can be any negative number. It's still the same effect that's going to happen. So let's look at what happens here. So this time, it's still going to be negative 1x plus 0. So we're going to start at the center, at the origin again. But this time, instead of increasing, again, we know our line's going to decrease. So our slope here is a negative 1 over 1, technically, because it has to be a fraction. So to look at the change that occurs here, I'm actually going to start and move down 1 and over 1. So our next point is going to be right here on the graph. And again, I will continue down 1 and over 1. And if I continue that effect all the way till the end, what you're going to see is that this line is in fact decreasing. Now, if I run out of room there, I can go back to the origin, go up and then to the left one if I want to move in the opposite direction. So again, that's creating my stair-step effect, and the line this time would look something like this. It's decreasing. Now, the word that I want you to use when the m is a negative is this one is actually going to be reflected across the y-axis. So anytime you see that there is a negative sign, I want you to know that it's going to be reflected. So again, this is a very important word to know, and you'll see this a lot. So it's a reflection across the y-axis when the m is negative. All right, let's check out one more change. So this is a change in b. So still, I've left that parent function on the y-axis, and remember the graph for a parent function is y equals x, and this is again technically 1x plus 0. So this time what we're going to look at changing is changing this b here. So let's look at two different equations. Let's start with y equals, I'm going to leave the m this time as 1x, and I'm going to change the b to 3. So we'll make it a positive 3 to start with. So y equals 1x plus 3. When I change the b, I change the starting point of my graph. Again, because b is where you begin on your graph. So we're going to start this time not at 0, but at a positive 3 on my y-axis. Now, because the slope is still 1 over 1, it's going to run just right alongside this line. We're going to move up 1 and over 1 each time to create our graph. And if you remember from linear relations unit, anytime we have the same slope, the lines will run parallel to each other. So because I've left the slope alone this time, these lines are in fact parallel. Now the change that has occurred that I want you to identify is that how the line has shifted on the y-axis. This y-axis runs very important for us. So initially we started here and now we're starting here. So because of that, we've actually shifted the line up. It's identical to the first one, but we've shifted it up 3 units. So this time when we changed the B, this was actually a shift up 3 units. And that's what I would expect you to identify for me here. Let's look at one more change in B. I looked at a positive 3. Now let's look and see if I change it to a negative 3, if that changes anything. So again, I'm going to leave that slope alone. I'm going to leave it 1 over 1x. And instead of a positive 3, let's make it a negative 3. So again, because I changed that B, I'm changing the starting point on my graph. And this time it's not going to be a positive 3 because my B is negative. It's actually going to move down to a negative 3. So we're going to start at a negative 3. And again, we're going to follow that same slope. So it's going to be up 1 and over 1 still. And again, it should run parallel because it has the same slope, same rate of change. So this new graph would look something like this. And again, we haven't changed a lot about it other than where it starts at. And again, it used to start at the origin. Now it starts here down on the graph. So this time, instead of starting at the origin, we move down. So this time it's going to be a shift down, and it's 3 units again. And because I've said down, I don't have to say that it's a negative. You can, but it's a shift down, which assumes that it's going to be a negative. So shift down 3 units. So to review again, there's 3 changes that can occur. We can change the m. If the m is greater than 1, it was going to be steeper. If the m is between 0 and 1, most of the time meaning a fraction, it will be less steep. When the m is negative, the graph reflects. And then there's changes to b. B is positive, the line shifts up. And if b is negative, the line shifts down. So your keywords are, is steeper or less steep, it could reflect, or it could shift up or down. So let's look at how to identify if there has been any changes that occurred. If it's from an equation, it's pretty easy to see, but when given a table, it's a little bit harder. So the first thing we have to do is, of course, identify our m and our b. Okay, remember, m is found by looking at the change in y over the change in x. So if I'm looking at how the graph is changing or the table is changing, I want to see the pattern here on the y side and the pattern here on the x side. So what you should notice on the y is that we're actually adding 4 every single time. Now, on the x side, it's just increasing by 1, so it's a plus 1. So if I'm looking at the changes in y, the change in y is 4, while the change in x is 1. So therefore, the m, or my slope in this equation, is going to be 4 over 1, or just 4. Now, the b is found by looking at where the x is equal to 0. And it's always going to be that on a table. It's the starting point. It's where x is nothing, where it's 0. So the b here, the y value, is going to be 0. So again, our b is 0. Now, remember from the parent equation, the parent, our slope, is going to be 1. As we saw before, it's very simple, and the b is going to be 0. So we're looking at the changes that have occurred here. So basically I want to know, did the m change? Is it still 1? Well, of course it's not. It's increased. It's now a 4. And as I said before, when the m is greater than 1, which it is in this case, it's going to change the steepness of it. So based on that, I know that this graph is going to be steeper. Let me back up. The graph is going to be steeper than the parent function. It's not changed to a negative, so it's not been reflected. And then now I want to see if it's shifted any. So has the b changed? Well, it's not changed. It's still 0. So therefore, the only change that has occurred is that the graph is going to be steeper. All right, let's try one more. So again, when I'm identifying it from my table, I want to find the m and the b. Okay, remember, m is found by looking at the change in y over the change in x. And the b is found by looking to where x is equal to 0. Okay, so let's start with our m. To find our m here, we're looking for the change in y. So basically what's happening to my y's, and what you should notice is that it's increasing by 3 each time. And then again, what's happening to the x's. So on the x side of it, it's increasing by 1. So this is adding 1. So the change in the change in y is going to be 3, where the change in x is going to be 1. So really this slope then is 3. Now, again, to find the b, I just look to where the x is equal to 0. So my b here is going to be 10. Now, from the parent function again, I'm looking to see, has the m changed and has the b changed? So this time, the m is no longer 1, it is now a 3, which means the first prediction is the graph is going to be steeper than the original because it's greater than 1. It's not reflected because it's not a negative. If it were a -3, it would be reflected, but it's not. And then the third thing I look at is, has the b changed? Is it greater than or less than 0, basically? So this one is actually greater than 0. So because it's greater than 0, it's going to be a shift up, and it's a shift up 10 units in this case because it's now a positive 10. So these are the two transformations that have occurred, and this is what you'd be expected to identify if you were asked this question here.